Hello everyone, welcome to Coders Camp. We are at 25th day of June LeetCode challenge, and the problem we are going to cover in this video is redundant connection. So the input given here is a set of edges that represent a unidirectional graph, and we have an extra edge that makes this tree to a graph, and we have to find that edge and return it back to our result. So here they have given one more condition that if there are multiple answers, return the answer that occurs last in the input. But this statement is quite contradictory to another statement given in the problem statement, that is, the nodes are labeled from 1 to n and with one additional edge added. So the problem statement itself said there will be only one additional edge added. So if there are multiple answers, return the answer that occurs last is going to be a contradictory statement where only one edge is going to be our output. So there can be no chances of existing a multiple answers. So yes, let's understand this problem with an example. So here is a given example in the problem statement where the given edges forms a unidirectional graph and we have to remove one edge in order to make it to a tree. So if we represent the same graph given in the input in the form of tree, then it is going to look like this. So starting from the very first edge, 1 to 2 there is a connection, again from 2 to 3 there is another connection, and 3 to 4 there is a connection, and connecting all these edges it is going to look like this. It is very evident from this tree that the connection from 1 to 4 is an extra edge that is making a cycle between this tree. So if we remove this from our tree, then it is going to look like a perfect tree instead of forming a cyclic graph. So how are we going to approach this in a problem? So since it is a graph problem, we can solve this using a basic DFS approach. So if we are trying to do a DFS to this problem, then considering each edge, we are going to traverse this graph without adding that edge to the graph. So if we can travel through this graph without having this edge considered, and if we can reach both the edges without this edge, then in that case, that is the duplicate edge we have to return. For example, consider the first edge 1, 2 where it is going to be considered as u, v. So now without considering this edge 1, 2, we are going to check whether we can reach 1 from 2 or 2 from 1. If suppose we can reach without having this edge, then in that case, that is the edge we need to return as our output. So if we are going to perform DFS approach to solve this problem, then it is going to take big O of n square time complexity to complete this solution. So how do we do it in an optimal way? So today let's take this opportunity to learn a new data structure, that is union find or disjoint sets. So we are going to get the help of this data structure in order to arrive at a solution. So as the name said, union find has two parts to it. The first is going to be union and the second is going to be find. So what does it perform? So this algorithm mainly helps us to work with disjoint sets. So first it consider all the elements as the different disjoint sets, and our union method is going to help us to combine or do union between two disjoint sets and make it to one set of one group. And same way, find is going to find at which set a particular element belongs to. For example, each set is going to have a parent. These 3 and 4 are individual sets, so they are its own parent. That is, 3's parent is 3 itself, 4's parent is 4 itself. So here in this set, we are going to identify a parent. So before joining any two sets, this set consider as having 1 as its parent and 2 as a member of this disjoint set. So now we are going to combine 1 and find 5, that is a purple set, along with the green set. So to do that, we have to find a common parent and connect the rest of the elements with that parent. So here the common element of the common parent is going to be 1. So we are going to combine this by having 1 as the root element or the parent and the rest of the element as its child. So after combining this purple group to a green group, our 1 is going to be common and 5 and 2 is going to be member of that group. So union is going to help us to combine these two disjoint sets as one, and find is going to help us find the parent of the set so that we will perform the union operation. So how does it exactly going to help us arrive at this particular solution? Here in this example, every edge given is a individual disjoint set. So we are going to combine each disjoint set to construct a tree. And if suppose we encounter a set is already existing in the tree, then that is the edge we are searching for. For example, start from our very first edge 1 comma 2. So 1 comma 2 is a disjoint set we are having right now. So we are going to add it to a main set where we construct our tree. So consider this is added to our main set where 1 and 2 is a single disjoint set which constructed a tree. So now comes the next edge 2 comma 3. So if you check, 2 is already existing in the set. So we have to decide a parent for this set. So the parent of the first set is going to be 1. So we are going to combine under the same parent. So we already have 2. So we are going to combine only 3 to the already existing set. So there comes another edge 3 comma 4 where 3 is already present and we have to insert 4 along with the previous set. So we have inserted 4 as well. So there comes 1 comma 4. So if you check, 1 is also there and 4 is also there. So if you insert this new edge to this existing tree, then it forms a cycle and that is making it to become a graph. So we are not going to add that to our existing set. Instead, we are going to return that as our output. And there comes another set 1 comma 5 where 1 is already exist and 5 is not there. So we are going to add 5 to the existing set. So here we found 1 comma 4 is going to be the duplicate edge that makes this tree to become a graph. And we are going to return that as our output. So this is the theoretical part of this, and how are we going to programmatically implement this? So the first step is we are going to assign parent to each node. So universally we have 5 nodes 1, 2, 3, 4 and 5, and initially they are going to be its own parent. It doesn't have any parent before inserting the edges. So now comes the edges. So first edge is 1 comma 2. So we have two nodes 1 and 2, and to combine this into a one single disjoint set, we are going to make the parent of 1 to another. Either the parent of 2 is going to be 1 or 1 is going to be 2. So let us first consider 1 is going to be the parent of 2 to make the connection. So this is now have joined as a disjoint set, and in our array we are going to update the parent of 2 to 1 because we have to find which group this 2 belongs to. So we gonna check that using the parent. First edge has been added. Now comes the second edge 2 comma 3. So 2 is already there. We are going to add 3 and we are going to add it under any group. So the group is going to be identified by a parent. So 2 is already there. 2's parent is 1. So since 2's parent is 1, we are going to consider the parent of that group as 1 and we are going to add 3 as well to the same group. So we are going to change the parent of 3 as well to 1 and add it to the set. So there comes another disjoint set 3 comma 4. Again 4 is going to be added under the same disjoint set. So let us make the parent of 4 as well to 1 and add it to our tree or the set. So these are things that is going to be maintained in a hash set programmatically. So now there comes the important part, that is the duplicate edge 1 comma 4. So if you check the parent array, it has been already updated to parent number 1, which means this 4 has already been belonged to a group which is existing. Also 1 is having its parent as 1, which is also same, which means they both already belong to the same disjoint set. So if we are trying to add this to a existing set, which means it is going to form a cycle, so which is going to be the output we are expecting and we are going to return it. So this is the overall idea of this algorithm and how that is going to help us solve this problem, and this is going to work in big O of n time complexity, as we are going to take each edges once to check its existence and add it to a group, and n is nothing but the number of edges given in the input. So let's go to the code now. So first, as I said, we are going to maintain a parent array, as this is the size mentioned here. So first I'm going to assign each node's parent to itself. So yes, but first let us write the find method before getting into the union part. So as I said, our find method is going to find in which set our actual node or edge belongs to. So here we identify a set by a parent, so which is nothing but an integer value. So each disjoint set would be having a parent of having an integer value. So it is going to recursively search for the parent of that particular node. If it is until it is not equal, then finally find the parent and return that as our output of this method. So here, going back to a main method, we are going to iterate the given edges in order to union it to a single tree. So this is nothing but for every edge we are taking, we consider the edges f and t, and we compare by using find method whether its parent is equal to its parent as well, which means they both belong to a same disjoint set. So if they both belong to same disjoint set, then that is the edge we are looking for. That is going to be our output. If not, we are going to find a parent of these two edges and combine that to a existing disjoint set. So by using again the find method itself, we are going to search for t's parent and assign it in the parent array. So yes, this is it. Let's run and try. Yeah, if not, finally return, which is nothing but a null value. Let's submit. Yes, the solution is accepted and runs in 1 millisecond. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.